Welcome to Teolumen Insights, where we reveal the hidden forces that shape the way you live and show you how to use them to create real transformation and supercharge your health, mindset, and daily life. Here are your hosts, Emma Greenwood and Nathan Sinclaire.
Welcome back to Teolumen Insights. Today we're taking a deep dive into the work of Avi Loeb.
Oh, Avi Loeb.
A prominent astrophysicist.
Yes.
Known for his bold ideas and willingness to kind of challenge conventional thinking.
Absolutely.
You've given us a stack of intriguing concepts from Loeb's work.
Yeah.
Touching everything from black holes and dark matter to quantum mechanics and the search for extraterrestrial intelligence.
It's going to be a wild ride.
Yeah, so buckle up.
What I find really fascinating about Loeb is his ability to kind of connect these seemingly disparate fields. He doesn't just stay within the confines of astrophysics.
Right.
He brings in ideas from physics, from history, from philosophy, even art to create this richer understanding of the universe and our place within it.
Okay, let's unpack that a little bit.
Sure.
One of the areas where Loeb really pushes the boundaries is in his exploration of black holes.
Yeah.
He uses this concept of the Schwarzschild radius,
Right.
which essentially defines the point of no return around a black hole.
Yeah.
Once you cross that boundary,
It's over.
even light can't escape that immense gravitational pull.
Well, and that boundary, that point of no return, we call that the event horizon.
The event horizon.
And Loeb uses this concept not just to explain the physics of black holes, but also to explore kind of the limitations of our current understanding of the universe.
I see.
It's like there are entire realms of reality that are hidden behind these cosmic event horizons, just waiting to be discovered.
And it's not just the massive black holes that we typically imagine.
Right.
Loeb also dives into the concept of primordial black holes.
Yes.
These hypothetical objects formed in the early universe that could be much smaller than typical black holes,
Right.
yet still incredibly dense and potentially powerful.
What's interesting is that Loeb connects these concepts to the possibility of advanced extraterrestrial civilizations.
Okay.
So he speculates that if these primordial black holes exist, a civilization that's capable of manipulating them could access incredible energy densities, potentially achieving feats that would seem like science fiction to us.
That brings us to the Kardashev scale,
Yeah.
a system for classifying civilizations based on their energy consumption. Right now, humanity sits at a Type 1 civilization,
Right.
harnessing the energy resources of our planet.
Yes.
But Loeb believes we need to aim for Type 2,
At least.
where we can harness the energy of our star, the sun.
Of course.
He even suggests that finding evidence of advanced extraterrestrial civilizations,
Yes.
perhaps those already at Type 2 or even higher, could provide valuable insights to accelerate our own technological progress.
Like having a cosmic roadmap,
Wow.
showing us what's possible and inspiring us to push the boundaries of our own capabilities.
But achieving Type 2 civilization would require overcoming some serious technological hurdles.
Oh, sure.
And that's where some of the other concepts you shared come into play,
Yes.
like quantum mechanical suppression.
Right.
Can you elaborate on that a little bit?
Yeah. Of course. So quantum mechanical suppression relates to the behavior of particles at the quantum level.
Okay.
And it suggests that there is this lower limit to how small a black hole can be, even though general relativity might suggest otherwise.
Okay.
You can imagine it as a kind of cosmic balancing act between the immense gravity of a black hole and the inherent uncertainty of quantum mechanics.
So even with the immense gravitational forces at play,
Yeah.
the bizarre rules of the quantum world still hold sway.
Exactly. And Loeb takes this concept a step further, speculating that advanced civilizations might be able to overcome this quantum mechanical suppression
Really?
and potentially create black holes that are smaller and more compact than anything we can even imagine, giving them access to even greater energy densities.
So this is where the concept of the Bohr radius comes in, right?
Yes.
Which defines the typical distance between an electron and the nucleus of an atom.
Right.
I'm guessing this relates to the scale of these theoretical mini black holes?
You're on the right track, yeah. So the Bohr radius helps us grasp the incredible smallness of these hypothetical objects.
I see.
Imagine compressing matter to a point where the laws of physics, as we know them, start to break down.
It's mind-boggling.
It is, yeah.
Okay, so we've got black holes, primordial black holes, and quantum mechanical suppression all swirling around here.
Right.
Where does Hawking radiation fit into this cosmic mix?
So Hawking radiation is another concept tied to black holes, but it flips the script a bit.
Okay.
Instead of matter being sucked in,
Right.
Hawking radiation suggests that black holes slowly leak energy over time
Really?
and eventually evaporate entirely.
Oh, wow.
It's a mind-bending concept that really challenges our understanding of these cosmic behemoths.
And I'm guessing Loeb connects this to the search for extraterrestrial intelligence as well.
Absolutely. He theorizes that advanced civilizations might be able to manipulate Hawking radiation, perhaps using it as a source of energy or even as a tool to communicate across interstellar distances.
So harnessing the energy of a dying black hole.
Imagine that.
Yeah, it's a wild thought.
It is.
This is already blowing my mind, and we're just scratching the surface of Loeb's ideas here.
There's more.
Let's dive a little deeper into the quantum realm.
Okay.
You mentioned the wave function,
Yes.
a fundamental concept in quantum mechanics that describes the probability of finding a particle in a particular state.
That's right.
How does Loeb connect this seemingly abstract concept to the search for extraterrestrial intelligence?
Well, Loeb takes the wave function concept and runs with it. He speculates that advanced civilizations might be able to manipulate wave functions on a macroscopic scale, potentially achieving feats like teleportation, matter creation, or even manipulating the flow of time.
Hold on. Manipulating the very fabric of reality?
Yeah.
That sounds like something straight out of science fiction.
It does, but
I'm starting to see a pattern here.
yeah.
Loeb seems to take these seemingly impossible concepts from physics and explore how an advanced civilization might be able to wield them.
Exactly. It's a thought-provoking approach that encourages us to think beyond our current technological limitations.
Okay.
And there's more. He also explores the potential of Rydberg energy levels.
Rydberg energy levels. Now, those describe the excited states of atoms when their electrons are in very high energy levels, far from the nucleus, right?
Right.
But how does that tie in to the search for extraterrestrial intelligence?
Loeb proposes that advanced civilizations might use Rydberg atoms as giant antennas for interstellar communication.
Okay.
Imagine these super excited atoms spanning vast distances,
Wow.
sensitive enough to detect and transmit signals across the galaxy.
That's a pretty incredible idea.
It is. It is.
Okay, so we've got black holes, quantum mechanics, and now giant atom antennas.
It's a lot.
It seems like there's no limit to Loeb's imagination.
That's what makes his work so captivating.
Yeah.
He's constantly pushing the boundaries of what we think is possible, inspiring us to consider new perspectives and explore uncharted territory.
This deep dive is already proving to be quite the journey.
Buckle up.
Let's see where else Loeb takes us.
And the journey continues. Another concept you shared from Loeb's work is the Compton wavelength.
Okay, the Compton wavelength that rings a bell from physics class, but refresh my memory.
Sure.
It has something to do with particles, right?
It does, yeah. It's essentially a fundamental property of a particle that relates its mass to its wavelength.
Okay.
Think of it as the smallest possible size a particle can be confined to according to quantum mechanics. It's like a tiny inherent fuzziness that each particle has.
So it's another example of those quantum mechanics rules blurring the lines of what we think we know about the universe.
Exactly. And as you might have guessed,
Yes.
Loeb sees the potential for advanced civilizations to manipulate this as well.
Oh, wow.
Imagine changing the very nature of particles,
Okay.
transforming one element into another, or even creating entirely new elements.
That's some serious cosmic alchemy.
It is.
Reminds me of the term electron capture, which you also mentioned. Isn't that a natural process where an electron is absorbed by an atom's nucleus?
Yes. It happens when a proton in the nucleus grabs an electron, transforms into a neutron, and releases a neutrino.
Okay.
Loeb suggests that advanced civilizations might be able to control this process.
Right.
To manipulate matter and energy in ways we can't even fathom.
This has given me a whole new perspective on what might be possible with advanced technology.
It is pretty amazing.
It's mind-boggling to think that we might be limited by our current understanding of physics.
Right.
And there could be entirely different ways to interact with the universe that we haven't even imagined yet.
It's a humbling thought.
It is.
Now, shifting gears a bit, let's talk about accretion rates.
Okay, accretion rates, I know that has something to do with black holes gobbling up matter, right?
Exactly. The accretion rate is the speed at which matter falls onto an object, like a black hole or a neutron star.
Okay.
As this matter spirals inward, it heats up and releases radiation, creating some of the brightest objects in the universe.
So the faster the accretion rate, the brighter the object.
In general, yes.
Okay.
And there's a specific type of accretion called Bondi accretion, where a compact object, like a black hole, pulls in matter from a surrounding gas cloud.
I see.
It's key to understanding how black holes grow and evolve over time.
So if an advanced civilization was able to manipulate these accretion processes,
Yes,
they could potentially control the energy output of these objects.
that's a possibility Loeb explores.
It's a lot of power.
Imagine harnessing the energy of a black hole's feeding frenzy.
Yeah.
It would be a game changer.
And how does the Debye length relate to all of this?
Okay.
I remember that it has to do with plasmas,
Uh-huh.
which is matter in a superheated state where electrons have been stripped from atoms, right?
You're right. Plasmas are all over the universe.
Yeah.
Stars, interstellar gas clouds, you name it.
Wow.
The Debye length tells us the distance over which charged particles in a plasma can interact.
So the Debye length basically governs the scale of interactions within a plasma.
Precisely. And Loeb suggests that advanced civilizations could manipulate plasmas,
Okay.
using their understanding of the Debye length to control energy flows, create force fields, or even propel spacecraft.
Hold on. Force fields and plasma propulsion. Are we talking Star Wars technology here?
It might sound like science fiction,
Yeah.
but it's all rooted in the principles of physics.
Okay.
And speaking of seemingly far-fetched ideas, Loeb also proposes using the solar system ephemeris to search for signs of extraterrestrial intelligence.
Now, I know the solar system ephemeris is like a celestial roadmap, detailing the positions and movements of all the objects in our solar system.
Right.
But how could we use that to find aliens?
By looking for anomalies. If we detect an object that deviates from its predicted path, it could be a natural phenomenon we haven't discovered yet,
Right?
or it could be something else entirely.
Something artificial.
Something artificial, guided by intelligence.
That's a pretty intriguing thought.
It is.
We're essentially using our knowledge of the solar system's choreography to look for unexpected dance moves.
Exactly. And it highlights Loeb's approach to science, being open to all possibilities, even those that might seem outlandish at first glance.
Speaking of things that might seem outlandish, let's talk about dark matter.
Okay.
It's this mysterious substance that makes up the vast majority of the universe's mass, but we can't see it directly.
Right. We only know it's there because of its gravitational effects on galaxies and other celestial objects. And Loeb, ever the innovator, suggests that advanced civilizations might have figured out how to manipulate dark matter.
Manipulating something we can't even see.
It's a wild thought.
What could they possibly do with it?
Well, he proposes some pretty mind-blowing possibilities.
Like what?
Imagine using dark matter as a source of energy,
Okay.
or even as a building material for creating wormholes.
Wormholes. Now that's some next-level cosmic engineering.
Oh, it is.
But aren't those still just theoretical?
They are, but that doesn't deter Loeb.
Of course not.
He encourages us to think big,
Right.
to consider ideas that might seem impossible today but could become reality tomorrow.
I like that.
And on that note, let's talk about tachyons.
Tachyons, the hypothetical particles that always travel faster than light.
Yes.
I've always been fascinated by the idea of breaking the cosmic speed limit.
It's a tantalizing thought.
But doesn't Einstein's theory of the relativity say that's impossible?
It's the prevailing view in physics, yes. But Loeb, ever the provocateur, explores the possibility that tachyons might exist,
Okay.
and that advanced civilizations might have found ways to use them for faster-than-light communication or travel.
So we're venturing into the realm of science fiction again.
Perhaps, but remember, what seems like science fiction today could be science fact tomorrow.
True.
Loeb's point is that we should be open to all possibilities.
Okay, I'm trying to keep an open mind here, but wouldn't faster-than-light travel completely upend our understanding of physics?
It would raise some serious questions about our current models.
Yeah.
Particularly about Lorentz invariance.
Right. Lorentz invariance, that's the principle that says the laws of physics are the same for all observers, regardless of their relative motion.
Exactly.
It's a cornerstone of Einstein's theory of relativity.
It is, and if faster-than-light travel were possible, it would suggest that Lorentz invariance might not be as absolute as we currently believe.
Wow.
It would be a major paradigm shift in our understanding of the universe.
This is getting pretty heavy.
Yeah.
So much for keeping an open mind. My brain is starting to hurt.
Don't worry, it's all part of the fun. Exploring these mind-bending concepts is what makes Loeb's work so captivating.
All right, let's keep going.
And there's still more to uncover.
Okay.
You also mentioned group velocity in your notes.
Yes, group velocity.
Yes.
It's the speed at which a group of waves travels.
Right.
And it can be different from the speed of the individual waves within the group.
That's right. And Loeb explores the possibility that advanced civilizations might be able to manipulate group velocity to transmit signals faster than light, even if the individual waves themselves are still bound by the cosmic speed limit.
Okay, so it's like a loophole in the laws of physics.
In a way, yes, it's a subtle and complex concept, but it shows how an advanced understanding of physics could potentially be used to achieve seemingly impossible feats.
It's pretty incredible.
And it's not just about speed, it's about manipulating space-time itself.
Is that where null geodesics come in?
Okay.
I remember reading that a null geodesic is the path that light takes through space-time.
Precisely. It's the shortest possible path between 2 points in curved space-time,
Uh-huh.
as described by Einstein's theory of general relativity.
Okay.
And Loeb suggests that advanced civilizations might be able to manipulate these null geodesics,
Really?
bending space-time itself to create shortcuts, wormholes, or even entirely new pathways through the universe.
This is blowing my mind again. We've gone from tiny particles to the fabric of space-time itself.
It's quite a journey.
Loeb's work really does encompass the full spectrum of the universe, from the smallest scales to the largest.
And that's what makes it so profound.
Yeah.
It forces us to reconsider our assumptions about reality, to question what we think we know,
Right.
and to embrace the vast possibilities that might lie beyond our current understanding.
This deep dive is truly living up to its name. We've explored so much, and I feel like we've only just scratched the surface of Loeb's fascinating work.
And the exploration continues. There are even more intriguing concepts waiting to be explored. It's amazing to think that we've only just scratched the surface of Loeb's work.
I know, right? It really makes you think.
He really does challenge us to reconsider our assumptions about the universe and our place within it.
Yeah.
One of the things I admire most about Loeb is his willingness to kind of question the traditional scientific method. He argues that we need to be more open to anomalies and unexpected observations,
Okay.
not just dismiss them because they don't fit our existing paradigms.
So that's where his idea of junior moments comes in, right?
Sort of
These
what
moments
is.
when young scientists, or anyone really,
Yeah.
ask the naive questions that can challenge established thinking and lead to breakthroughs.
Right. Right.
It reminds me of the saying, the only stupid question is the one you don't ask.
Exactly. It's about fostering a sense of curiosity and wonder, encouraging exploration, and a willingness to challenge the status quo.
I like that.
Loeb also emphasizes the importance of an interdisciplinary approach,
Okay.
drawing connections between fields that might seem unrelated at first glance.
Interesting.
He sees astrophysics as intertwined with philosophy, with history,
Wow.
even art.
Really? So it's about seeing the bigger picture,
It is.
understanding the human context of scientific exploration.
And part of that human context is recognizing the limitations of our current knowledge.
Right.
Loeb often talks about the vastness of the universe and the likelihood that there are things out there so far beyond our comprehension that we can't even imagine them.
It's humbling, to say the least.
It is.
It makes you realize that what we know is just a tiny drop in a vast cosmic ocean.
But it's also incredibly exciting.
It is.
It means there's so much more to learn, so many mysteries yet to unravel.
Yeah.
Loeb wants us to embrace that mystery,
Okay.
to keep asking questions,
Right.
to keep pushing the boundaries of what we think is possible.
This deep dive has been a real eye-opener for me.
Good.
Loeb's work has given me a whole new perspective on the universe and the potential for what might be out there.
It's been a pleasure exploring these ideas with you.
Likewise.
Loeb's willingness to challenge conventional wisdom and his kind of infectious enthusiasm for discovery are truly inspiring.
Absolutely. And on that note, this has been Teolumen Insights.
Great talking with you.
What stood out to you the most from this deep dive into Loeb's work? What will you be pondering as you gaze up at the stars tonight? What if everything we think we know about the universe is just the beginning of the story? Keep exploring, keep asking questions, and keep looking up.